Hello students, welcome to MAGESH classes. In this presentation, we are going to discuss about +1 Chemistry, Unit 8, Physical and Chemical Equilibrium, book back questions. Totally we have 25 questions. In the part 1, we are going to discuss about question from 1 to 14, and in the part 2, we will be discussing from 15 to 25. Let us move into the question part. Question number 1. If Kb and Kf for the reversible reactions are 0.8 into 10 power minus 5 and 1.6 into 10 power minus 4 respectively, the value of the equilibrium constant Kb and Kf. What is Kb and what is Kf, and what is the relation between the Kc? The given one, the Kb. First, writing the equation, for example, A gives B. Reactions. It is a reversible reaction. The Kb is the rate constant of the backward reaction, and Kf is the rate constant of forward reaction. Then the relation between the rate constant and the equilibrium constant is Kc is equal to K forward divided by Kb. K is the rate constant. Here the given values are Kf and Kb, and the equilibrium constant is in the question. And the Kb and Kf values are in the following order. So the Kf is equal to 1.6 into 10 to the power of minus 4, and Kb is equal to 0.8 into 10 to the power of minus 5. So if by substituting this value, what do you get? 1.6 into 10 to the power of minus 4 divided by 0.8 into 10 to the power of minus 5. So by cancelling this value, you get 1.6 into 10 to the power of 1 divided by 0.8. So this will give it 2 into 10 power 1 is equal to 20. So our answer is A. Question number 2. At a given temperature and pressure, the equilibrium constant values for the equilibria. Two equations are given. The first equation, the equilibrium constant is K1, and the second equation, the equilibrium constant is K2, and the relation between K1 and K2. To solve, consider this equation. A plus B gives C plus D. The equilibrium constant is K1. Suppose this equation is multiplied throughout by 2, it will be 2C2D. Here it is multiplied by 2. The equilibrium constant is K2. Then what is the relation between K1 and K2? The K2 is equal to the square of the K1. Suppose it is multiplied by 3, that is 3A plus 3B gives 3C plus 3D. The equilibrium constant K3 is K3 is equal to K1 power 3. Suppose the reaction is divided by 2, that is 1 by 2 moles of A plus 1 by 2 moles of B gives 1 by 2 moles of C plus 1 by 2 moles of D. It is K4. This K4 is equal to square root of K1, or it is K1 power 1 by 2. Okay. When the equation is inverted, reversed, that is the product is in the side of reactant and the reactant is in the side of the product. The equilibrium constant is K5. The K5 is nothing, it is 1 by K1. Equilibrium constant is inverted. Now you consider the first equation and second equation. The reactants are in the product side, so it is inverted and it is divided by 2. So there are two operations, one is inverted and another one is divided by 2. So K2 is equal to 1 by K1 for the inversion, and divided by 2, it is root, or it is equal to 1 by K1 power 1 by 2, or it is K1 power minus 1 by 2. So K2 is equal to K1 power minus 2. Our answer is B. Clear? Question number 3. The equilibrium constant for a reaction at room temperature is K1, and that at 700 Kelvin it is K2, and K1 is greater than K2, then the conditions. From the given data at room temperature, K1, room temperature about 30 degree, 300 Kelvin, 30 degrees Celsius, about 27 degrees Celsius. And at 700 Kelvin, the value is given K2. The equilibrium constant K1 or K is equal to concentration of the product at equilibrium and the concentration of the reactants at equilibrium. Okay, here the temperature raised, the K2 value is decreased because the condition is given K1 is greater than K2. As temperature increased, K2 decreased. The K is equal to concentration of the product divided by concentration of the reactants. The concept is, as temperature increases, Kc decreases, the reaction is exothermic equilibrium, and temperature increases, Kc increases, it is a endothermic equilibrium reaction. So it is a exothermic equilibrium reaction from this data. So forward reaction is exo, backward reaction is endo. Using this data, this forward is exo and backward is endo. So the first case, the forward reaction is exothermic, correct statement. And the forward reaction is endothermic. The backward reaction is endothermic. The reaction does not attain equilibrium. So it attains the equilibrium, then only you get the equilibrium constant. The reverse reaction is exothermic. So these two are in the opposite one. So your answer is forward is exothermic. So overall the concept is, as temperature increases, Kc decreases, it is exothermic equilibrium reaction. Temperature increases, Kc increases, it is an endothermic equilibrium reaction. In exothermic equilibrium reaction, forward is exo, backward is endo. In endothermic equilibrium reaction, forward is endo, backward is exo. The given data, the temperature is raised. Room temperature only it is 300 Kelvin, and in the temperature raised, the K2 is decreased. And so it is exothermic reaction. Clear? Question number 4. The formation of ammonia from nitrogen and hydrogen is reversible reaction. What is the effect of increase of temperature on this equilibrium reaction? The given reaction is exothermic reaction because the heat is produced, exothermic equilibrium reactions. We have learned from the previous question, in exothermic reaction, forward is exo and backward is endo. So the given reaction, nitrogen plus 3 moles of hydrogen gives reversible reaction, 2 moles of ammonia and heat. So forward reaction is exo, backward reaction is endo. Here the effect is increase of temperature. As temperature increases, what happens? Endothermic reaction is failed. Okay, that is the backward reaction is failed. Backward reaction only endo. So the equilibrium is shifted to the left. This is the answer. Question number 5. The solubility of carbon dioxide gas in cold water can be increased by increase in pressure, decrease in pressure, increase in volume. It is also decrease in pressure. None of this. So from the option itself, the two are same, the decrease in pressure and increase in volume. Okay. Now consider the equation. What is the solubility of carbon dioxide? By writing the equation, carbon dioxide is a gas dissolving in water. It is a liquid. To give the carbonic acid, it is also the liquid. So the volume of the reactant side, volume of the product side. Volume of the reactant side, the gas is present. The volume of the reactant is greater. It is in equilibrium. In equilibrium, when pressure is applied, the system moves or shifts towards the direction where the volume is less. Volume is less. So as P increases, the equilibrium shifts towards the direction where the volume is less. So in case of this reaction, the product side, the volume is less. So applying pressure, what happens? The reaction is shifted towards the right hand side. So the carbon dioxide solubility is increased by increase of pressure, so that the carbon dioxide is converted into carbonic acid in the forward direction. Carbon dioxide consumed in the forward direction, and in case of the reaction, the volume is less in case of the right hand side. According to equilibrium concept, when the pressure is increased, the volume is decreased. So system moves towards the direction where the volume is less. So right hand side, the volume is less, and so increase of pressure, the solubility increases. So the general concept, solubility also increases by the pressure. When you consider the B and C, the decrease of pressure and increase of volume both are same. So this may not be answer. Where answer is increase in pressure. Question number 6. Which one of the following statement is correct? Incorrect statement. For a system at equilibrium, Q is always less than the equilibrium constant. First of all, Q is reaction quotient. It is defined as the concentration of the product divided by concentration of the reactants in the equilibrium reaction. And the Kc is equal to ratio of the concentration of the products to the ratio of the reactants. Then what is the difference? It is the concentration at equilibrium condition, and it is in the non-equilibrium condition. So the first statement for a system at equilibrium Q is always less than the equilibrium constant is wrong. At equilibrium, the Q is equal to Kc. So it is non-equilibrium condition. It is said to be reaction quotient. At the equilibrium condition, the ratio is said to be equilibrium constant. So the statement at equilibrium, Q is always less than the equilibrium constant is a incorrect statement. Then equilibrium can be attained from the either side of the reaction. Correct. Presence of the catalyst affect both the forward reaction as well as the reaction. It is also correct. So in the reaction is altered by the catalyst, it alters the speed of the reaction, both the forward and backward direction. Equilibrium constant is varied with the temperature. That is, temperature increases, the equilibrium constant values also vary. So it is right statement. So A is the incorrect statement. Question number 7. K1 and K2 are the equilibrium constants for the reactions respectively. So this is nitrogen plus oxygen gives nitric oxide. The K1 is the equilibrium constant. Nitric oxide and oxidized to give nitrogen dioxide. It is given K2. And what is the equilibrium constant for this? The reaction, the dissociation of nitrogen dioxide to nitrogen and oxygen. It is K3 or K. So what is the relation from this equation? The given equation, NO2 gives half N2 plus oxygen. This equation is obtained from inverting the first one. So this is first equation, this second. Inverting the first one, what do you get? The 2NO gas to gives N2 gas plus oxygen gas. So first of the reaction is inverted. And in the next, and so this value is 1 by K1. And now to obtain this 1 by 2 nitrogen and oxygen, this equation is divided by 2. So by dividing 2, you get 1 mole of NO, half N2 and half oxygen. So for the division, this value is 1 by K1, root K1. To get nitrogen dioxide in the left hand side, the second equation is also inverted. So K for this equation is 1 by K2. To obtain 1 mole of NO2, this second equation is also divided by 2. For the division by 2, this Kc is also 1 by K2. To obtain this required equation, we have to add the two equations, the modified equation, this and this. By adding this modified equation, you get the NO in opposite direction cancel. So you get the NO2 gives of nitrogen plus 1 mole of oxygen. So this is the equation you got. And what is the value for this equation? It is 1 by root of K1. This is 1 by root of K2. When the equilibrium constants are, the value of equilibrium constants are added, the magnitude of these values will be multiplied. So the resulting K is equal to 1 by root of K1 into 1 by root of K2. This is equal to 1 by root of K1 into K2, or this is equal to 1 by K1 into K2 of. So this is your answer, A. By consolidation, it is very simple. In order to obtain the equilibrium constant in question, the first is inverted, reversed, so the value is 1 by K1. To obtain 1 mole of NO, it is divided by 2, and so it is 1 by root of K1. And the second equation is also inverted, 1 by K2 and divided by 2. You got two equations. By adding this equation, you get the resultant equation. By adding the equation, you have to multiply the rate constant, equilibrium constant values, and so this value is equal to 1 by K1, root K1 into root K2. This is equal to 1 by root of K1 into K2. Your answer is A. Question number 8. In the equilibrium, 2A gives 2B plus C2. The equilibrium concentrations of A, B, and C2 at 400 Kelvin are 1 into 10 power minus 4 m, 2.0 into 10 power minus 3 m, 1.5 into 10 power minus 4 m respectively. The value of Kc for equilibrium at 400 Kelvin is. It is very simple, direct calculation. What is the equation given? The given equation 2A gives 2B plus C2. By writing equilibrium constant Kc is equal to concentration of B power 2, the coefficient, and concentration of the C2 at equilibrium, and divided by the concentration of A power 2 at equilibrium concentration. Equilibrium concentrations are given in the question. The equilibrium concentration of A, B, C are in the respectively. So A is concentration of A is equal to 1 into 10 to the power of minus 4 m. Concentration of B B is equal to 2.0 into 10 power minus 3 m. Concentration of C2 is equal to 1.5 into 10 to the power of minus 4 m. By substituting the value in the Kc expression, Kc is equal to the concentration of B. This is given 2.0 into 10 to the power of minus 3 power 2 into concentration of C. It is 1.5 into 10 to the power of minus 4 divided by A. Active mass of A is equal to our concentration minus 4 power 2. By solving this, what do you get? 4 into 10 to the power of minus 6 into 1.5 into 10 to the power of minus 4 divided by 10 to the power of minus 8. 4 into 1.5 is equal to 6 and the power is 10 to the power of minus 10 divided by 10 to the power of minus 8. This is equal to 6 into 10 to the power of minus 2. This is equal to 0.06. The Kc value is A. Question number 9. An equilibrium constant of 3.2 into 10 to the power of minus 6 for a reaction means the equilibrium is in the forward direction or in the reverse direction. Never establish none of this. For a reaction, Kc is equal to concentrations of products at equilibrium condition divided by concentration of reactants at equilibrium condition. The Kc value is given 3.2 into 10 to the power of minus 6 is equal to active mass of or concentration of product at equilibrium condition upon reactants constant. Here the Kc value is small, that is equal to about 10 to the power of minus 6. For the smaller value, the reactant concentration and the product concentration, from the equation, the reactant is greater. So the reactance is greater in direction, and so it favors the backward direction. So in equation, reactant gives product. In order to obtain the Kc minus 6, the reactance value should be greater. So the equilibrium shifts towards the reactant direction, that is in the reverse direction. Your answer is B. Suppose the equilibrium is greater than 1. It means it favors the reaction in the forward. Question number 10. Kc upon Kp for the reaction. Nitrogen gas plus 3 hydrogen gas equilibrium to gives 2 moles of ammonia in gaseous condition. The Kp and Kc is related by delta Ng. Delta Ng is equal to number of moles of gaseous products, Ng of the product, minus number of moles of gaseous reactants. In this reaction, del Ng is equal to 2 in the product side and 3 plus 1 mole, 4 in the reactant side. This is equal to minus 2. By substituting, Kp is equal to Kc into Rt power minus 2, or this is Kp is equal to Kc divided by Rt power 2. Kc by Kp is equal to Rt square. So the answer is D. Question number 11. For the reaction AB gives A gas, B gas at equilibrium. AB is 20% dissociated at a total pressure of P. The equilibrium constant Kp is related to the total pressure by the expression. The given reaction AB gives A plus B. To derive the Kp value, we have to consider the following steps to find out the partial pressure of the A, B and AB. Okay. See here the number of moles. Initially, we have 100 moles of AB and 0 moles of A and 0 moles of B in the container. At equilibrium, number of moles dissociated. So initially you have 100. The dissociated at equilibrium is 20. Here no dissociation. And number of moles at equilibrium. Equilibrium is equal to 100 minus 20, it is 80. Here 1 mole of AB is dissociated, you get 1 mole of A and 1 mole of B. Here 20 mole is dissociated, so you get 20 moles of A and 20 moles of B. Then total. Total is equal to 80 plus 20 plus 20 is equal to 120 moles. And writing Kp, that is equilibrium constant, Kp is equal to partial pressure of A into partial pressure of B divided by partial pressure of AB. So from that we have to find out the partial pressure of A. The partial pressure is obtained by mole fraction into total pressure. Say total pressure P, capital P. Partial pressure is given small p. So from the expression, the partial pressure of A is equal to the mole fraction of A, that is number of moles is equal to 20 to the total moles is 120 and the total pressure is P. And we can write partial pressure of B is equal to 20 divided by 120 into total pressure. Partial pressure of AB is equal to 80. It is the number of moles at equilibrium divided by total moles 120 into capital P. So these partial pressures of AB and AB is substituted in the Kp expressions. By substituting this value in the Kp expression, Kp is equal to partial pressure of A, it is 20 divided by 120 into P into 20 divided by 120 into P. This partial pressure of B divided by 80 divided by 120 into, this is equal to 20 divided by 120 into P into 20 divided by 120 into P into 120 divided by 80 into P. Here the P cancelled, 120 is cancelled, and 120 here the 20, it is 6, okay, and 20 this will be 4. So this is equal to P divided by 24 Kp. So in question, the Kp and equilibrium constant, the Kp is related to the partial total pressure P by the expression. So this is the total pressure and it is a equilibrium constant Kp. So we can write 24 Kp is equal to P. Our answer is C. Question number 12. In which of the following equilibrium Kp and Kc are not equal? Kp and Kc is related by the equation Kp is equal to Kc into RT power del Ng. Here 3 cases, del Ng is equal to 0, then Kp is equal to Kc. Del Ng is positive. What is the value? It is Kp into Kc into RT. So Kp is greater than Kc. And del Ng is negative. The Kc is greater than Kp. So in case of A, the del Ng is equal to number of moles of product is 1 plus 1, 2, here 2. So 2 minus 2 is equal to 0. So Kp is equal to Kc. The question is, which of the following equilibrium Kp and Kc are not equal? The second case, number of moles 1, 1, 1, 1. So del Ng is equal to 0. 2 minus 2, 0. So this is, in this reaction, Kp is equal to Kc. Here 2 moles in the product side and 1 plus 1 in the reactant side. Here also Kp is equal to Kc. Del Ng is equal to 0. Here 1, 1, 1. So del Ng is equal to 1. By substituting this value in the expression Kp is equal to Kc into Rt power 1. So it is positive, and so Kp is greater than Kc. It is not equal. So your answer is D. Number 13. If X is a fraction of PCl5 dissociated at equilibrium in the reaction, PCl5 gives PCl3 plus chlorine. Then starting with 0.5 mole of PCl5, the total number of moles of reactants and products at equilibrium is. The given equation is dissociation of PCl5. By writing Kp, this is equal to concentration of PCl3 into concentration of chlorine divided by concentration of PCl5. So it is obtained number of moles at initially it is 0.5 mole of PCl5 taken, 0.5 mole, here 0 mole in the container. And at equilibrium, number of moles dissociated, Bx. Here no dissociation, it is only the formation as such. Number of moles at equilibrium is equal to 0.5 minus x. Clear? When consider the stoichiometric equation, 1 mole of PCl5 dissociate to give 1 mole of PCl3 and 1 mole of chlorine. Here number of moles dissociated is x. So x mole of PCl3 and x mole of chlorine is obtained. Total is equal to 0.5 minus x plus x plus x. So this is equal to 0.5 plus x. The question is total number of moles of reactants and product. Your answer is 0.5 plus x. So answer is B. Values of Kp1, Kp2 for the reactions. X gives Y plus Z, A gives to B are in the ratio 9:1. If the degree of dissociation and initial concentration of X and AB equal, then total pressure at equilibrium P1 and P2 are in the ratio. Two reactions are given, two Kp values are given, and the ratio of the total pressure of two reactions are in the question. The given data, the two reactions, one is X gives Y plus Z, the Kp1 is 9, P1, total pressure. A gives to B, it is Kp2, 1, and the total pressure is P2. The initial concentration is equal to A. So by comparing the two equations, first you have to calculate the Kp1 and Kp2 value in the expression format. Then only you can relate the total pressure P1 and P2. For that, the two reaction X, Y, Z, here A is the reactant, B is the product. The moles. Initial number of moles are same, answer it is written as A. And in case of this expression, here also A. Here 0, 0, 0. The number of moles reacted, say X moles. Here no reactions, it is also X moles. Number of moles at equilibrium is A minus X. Here X, because 1 mole gives 1 mole of Y and 1 mole of Z, and here A minus X, here 2X, because in the stoichiometric format 1 mole of A gives 2 moles of B. Total moles A minus X plus X plus X, it is equal to A plus X. A minus X plus 2x, here also A plus x. By writing Kp expression, Kp1 is equal to partial pressure of y into partial pressure of z divided by partial pressure of x. Here the Kp2 is equal to partial pressure of b power 2 upon partial pressure of A. Partial pressure is obtained by mole fraction into total pressure. Here it is P1, here the total pressure is P2, it is Kp2, Kp1, equilibrium constant. So Kp1 is equal to partial pressure of y is equal to mole fraction into total pressure. What is the mole fraction? The moles of the substance divided by total moles into P1. It is the partial pressure of y. Partial pressure of Z is equal to x divided by A plus x into P1. Partial pressure of this x equal to x divided by A plus x into P1. Here the partial pressure of A is equal to number of moles at equilibrium A minus x divided by total moles A plus x into total pressure given B2. Partial pressure of B is equal to 2x at equilibrium total moles into mole total pressure P2. By substituting this partial pressure on the equilibrium constant expression, what we get? Kp1 is equal to partial pressure of y, this is x divided by A plus x into P1 into x divided by A plus x P1 divided by A minus x divided by A plus x into P1. So here it is A minus x. Partial pressure of Kpb is 2x divided by A plus x into P2 square divided by A minus x upon A plus x into P2 total pressure. X square P1 square divided by A plus x whole square into A plus x divided by A minus x into P1. So this cancelling and A plus x is cancelled. Finally get x square P1 divided by A plus x into A minus x. Here the Kp2 is equal to 4x squared P2 square divided by A plus x whole square into A plus x divided by A minus x into P2. So cancelling P2, A plus x, you get Kp2 is equal to 4x squared into pressure divided by A minus x into A plus x. Kp1. So you can write in the question the ratio of Kp1 Kp2 is equal to 9:1, 9 divided by 1. This is equal to the partial pressure P1 by P2, that is 4P2. P1 by P2 is equal to 36 divided by 1. So this relation given that 36 is to 1. So cross multiplication 36 P2 is equal to P1. So P1 by P2 is equal to 36 divided by 1. This is equal to 36 1. Our option is A. Problem is solved by comparing the two Kp1 and Kp2 with the total pressure P1 and P2. Okay students, up to this we have stopped this part, and in the second part we have continued from 15th to 25. I hope that it is useful to you. Thank you for spending your time. Thank you for watching.